welcome back, guys. Moving on to the next test. We got 3 expressions here to simplify, and I'm going to go through them one by one. So starting with number 1, we got 8x to the 6, y to the negative 3, and that's all to the power of 1 over 3. And then we have 2xy, and that's all to the power of 3. So what I'm going to do here is I'm going to distribute these 2 exponents inside their respective brackets. So the 8 will go to the power of 1 over 3. This x to the 6 will go to the power of 1 over 3. And then this y to the negative 3 will go to the power of 1 over 3. And this is going to be all over. The 2 will go to the power of 3, x will go to the power of 3, and then y will go to the power of 3. Then from here, just simplify. So we know 8 to the power of 1 over 3, that's like the third root of 8, which is 2. 6 times 1 over 3, that gives us x to the 2. Y to the negative 3 to the power of 1 over 3, multiply the exponents, negative 3 times 1 over 3 gives us negative 1. And this is all over. 2 to the power of 3 is 8. And then we have x to the 3, and then we have y to the 3. And then we can simplify it from here. So 2 over 8, we know that simplifies to 1 over 4. So we'll have 1 over 4 for the coefficients. And then we have x to the 2 over x to the 3. Well, 2x is at the top, 3x is at the bottom, means that we are left with 1x at the bottom. So that's going to go here. And then we got y negative 1 over y to the 3. Well, this y to the negative 1 we could bring down to the denominator. So we'd have y to the 1 times y to the 3. Right, all in the denominator, so that would be 1 over y to the 4. So this ends up being y to the 4 in the denominator. You could have also done negative 1 minus 3, which would give you y to the negative 4, which you bring down to the denominator because that exponent ends up being positive. Or, ends up being negative, and then when you bring it down, it ends up being positive. But anyway, that there is your final answer for number 1. I'm going to write it over here actually. Give myself some more room for the next one. So number 2 says 5x to the negative 1, y to the 2, all to the power of negative 2, all over 125 x to the 5, y to the negative 3. So a couple of things you could do here. You could bring this whole thing down to the denominator and then change this to a positive exponent. But because there's already a lot going on in the denominator, I'm going to keep it up here and I'm going to just distribute that negative 2 to everything. So I'm going to have 5 to the negative 2. And then I'm going to have x to the negative 1 to the negative 2. And then y to the power of 2 to the power of negative 2. All over. This would be 125 in the bottom. Then we have x to the 5 and then y to the negative 3. And then further simplifying this, so this 5 to the negative 2, I'm going to bring down to the denominator because it's a negative exponent. So when I bring it down, it's going to change to 5 to the power of positive 2. Negative 1 times negative 2, that gives us x to the power of 2. 2 times negative 2, that gives us negative 4 here. All over, I brought this down so it'll be 5 to the power of positive 2 times 125, and then we still have x to the 5 and then y to the negative 3. So from here, let's simplify as much as possible. So notice the x2 over x5, right? We could simplify those. What would we end up with? 2x's at the top, 5x's on the bottom means that we end up with 3x's on the bottom after the 2 on the top cancel out with 2 on the bottom. So we're going to be left with x cubed on the denominator, in the denominator. Here we have 5 to the power of 2, which is 25, and then 25 times 125, that gives us 3,125. And then there's no coefficients left up top, so there's just a 1 up top. x2 over x5, that simplifies to x3 in the denominator. And then we have y to the negative 4 over y to the negative 3. Well, we could just switch these, right? This negative comes up, becomes a positive. This negative comes down, becomes a positive. 3y's up top, 4y's at the bottom. We're left with 1y at the bottom. So it would simplify to that right there. Right? So sometimes I like to take expressions with the same base once I've simplified enough and do them on the side and then bring them back to our main simplification. Right? But either way, that's the answer that you should get. So I'm going to write it over here. We got 1 over 3,125 x to the 3 times y. And then finally we got number 3, square root of 1,024 x to the negative 1 to the power of 10 all over 2x to the negative 3, and that's all to the power of 5. So first thing I like to do with these types of questions is switch that radical on the outside to a rational exponent. So we'll have 1,024 x to the negative 1 to the power of 10 all over 2x to the negative 3 to the power of 5. This is going to be all to the power of 1 over 2. And then what I like to do before dealing with this exponent on the outside, I like to simplify what's on the inside if possible. So what will we have here? We'll have 1,024, negative 1 times 10, that gives us negative 10, all over this 5 I'm going to distribute in the bracket. So we'll have 2 to the power of 5, and we'll have x to the negative 3 to the power of 5, and this will be all to the power of 1 over 2. And then from here, 1,024 x to the negative 10, all over 2 to the power of 5 is 32. And then this ends up being x to the negative 15. And this will be all to the power of 1 over 2. And then further simplifying this, I'm going to continue up here. So 1,024 divided by 32, that is just 32. That stays in the numerator. Now this x to the negative 10 I'm going to bring down, this x to the negative 15 I'm going to bring up. So I'll have x to the 15 all over x to the 10 in the denominator, right? I just switched these two. This is still all to the power of 1 over 2. And then 15x's at the top, 10x's at the bottom, means that we're left with 5x's at the top. So we'll have 32 x to the 5, and this is all to the power of 1 over 2. And then we can just distribute that 1 over 2 inside the bracket. So we'll have 32 to the power of 1 over 2, and then x to the 5 to the power of 1 over 2. So from here, this is like the square root of 32, which is not a smooth number. And then 5 times 1 over 2, that's x 5 over 2. And then we could simplify this radical further here, right? So we can break this down into root 16 times root 2, right? 16 times 2 is 32. And then this x to the 5 over 2, we can't simplify that any further. And then the square root of 16 is 4. So 4 root 2, x to the power of 5 over 2. That's your final answer. So root 32 I simplified to 4 root 2. And you can actually put this x 5 over 2 as a radical as well if you want. So that could be 4 root 2. You could split this up. Here, I'll show you here. So x to the power of 5 over 2. You could split this up as x to the 5 to the power of 1 over 2, which would just be the square root of x to the 5. All right, so we can put the square root of x to the 5 if you want everything to be in radical terms. Another thing you could do with this is do it the other way. So you can put x to the 5 in the bracket and then the 1 over 2 on the outside, which would be the square root, or no, sorry, that's actually what we did before. So you can put x to the 1/2 to the power of 5. So you could have like the square root of x all to the power of 5. But I feel like this looks nicer. But I think you'd be okay if you just left your answer like this. If the x had a rational exponent and then you had a radical in front for the coefficient. But either way, this or that, those are the correct answers for, that's what number 3 simplifies to.